Hello, this is Max Straker. Just going to start this script off here, just kind of want it running in the background. So I posited this question. Two of my siblings passed away last year, and so I posited this question: which sibling lives longer? So I looked on the interwongle and searched around for some other things, and there didn't seem to be any data on it at all. So I thought, well, okay, then this is a nice exercise that I can actually do. So I thought, what data can I actually access? So the data that I'll just close that one there off. Which one am I doing here? I'm doing Smith. Okay, this one here, if we look at this one, it's actually finished and it's broken. What this one's doing is I've got Selenium WebDriver, which is coming through, and I'm doing it inside of Firefox, which is my preferred one. So it's going off and looking at the URL, and it's setting it up. It's then going onto the site through here. It's finding this element through here, and if I just right click on that one there and go inspect element, you'll see it's called, the name is called CSIR, and then it's putting in some data into there. It's then putting some data into this one here, which if I just go in and click on that one and we go inspect, it's actually saying C date lower, and the next one is C date upper. So it's looking for the surname, it's looking for the initial dates that you're looking at, and then your final dates that you're looking at. So within that, then we've got to come down and click this button. So if we just look at the code again, that's what we're doing. We've got the Selenium driver coming through, and when it actually finds that cell, it puts in the first name, puts in the two dates through there. It then finds this element through here by the XPath, and then the submit, we actually do a click on it. So we find the element, which is the second button, and we go and click onto that. And then we sleep and for 3 seconds, just to allow it to actually do the process through here. And then we go in and we look for the CSS selector, which is, if we look on the page, I don't know which one's got the search through here, on this one here, it's got the number of pages through here. Now, just on this particular result coming through here, the search result is given the maximum number of records have been retrieved. So that means within the bounds that we've got, it's going to give us up to 500. There might be 1,000 rows or matches, but it's only going to give us a maximum of 500. So it's only going to go, so if I can get 17 pages, then I know I've got the maximum, so I can actually use this. Now, if I use the pages, I can actually go on count, as in the number of pages, so I'll hit the maximum. But if I go on pages, I can then use that to count, to loop through them. But on this one here, it's crashed and burnt. So I suddenly thought, well, it's sort of, the concept's good, we just ain't quite got it right through there. So coming through again, we're just going to run it by, and we're going to run through and do this particular one through here. On this one here, it's going to go and find the number of pages that are in there, so that it knows how many that it's got to loop through. We then know that each page has 30 elements. Well, it has 31 because it has the header, and then it has 30 rows of data, and it's got 6 columns across, so that then we can actually loop through from 2 to, we actually count how many rows it's got through, and you see here it's broken again. So if we just go and look through this particular one through here, it's stopped and it hasn't closed back down again, so we haven't finished out cleanly. But on the very last page, it's only got 3, so it hasn't got 30 on this page. So although we actually know that there's only 3, it seems to stop. It doesn't seem to go through, and this is an issue that I actually had with this particular program. So on this particular one that I'm running through, it's gone to table Z1A. So if we just go to table Z1A, if we look right at the very bottom, the last one is called Lawrence John, and if we just go into here, we can see we've actually grabbed that data. So we got to here and then it's crashed, so it hasn't quite completed the loop and closed that down at the end, but we're getting there. So the next thing that we actually look through is that we have a number of names. What I was actually found when I actually just used one surname and went through the whole history from the earliest records which they have, which is from 1875 up to 1973, there was only so many. I actually did an exercise, I'll just briefly show you here, of the number of people that I've got from that whole list, where I've got the siblings coming through. So there wasn't a massive amount by the time I actually cleaned a lot of it out. Now there's a lot more to it than that, so this is a bit simplistic at this point in time. So I've got the information, but suddenly I think, well, I'm not going to get it all out of one name, so I'm going to need to have a lot of names. So therefore I went to another website that I found which had the 30 most common names of people in districts. So there was one for Auckland, one for Wellington, one for Christchurch, one for Horowhenua, and all of this sorts of things. And it had all the names. And so I scraped that site and got all of these names based on all of these different counties or whatever. And then when I actually had them, I had something like 400 names, but when I actually tried to do a duplicate and only got distinct, I ended up with about 100 names. So I ended up with this massive long list of 100 names, and then I sort of split them down. So in this one here, I wanted to be able to loop through them. Now, a couple of things, when I was doing this one here, I was using somewhere along the line, I've got a sleep. So I'm using the time to sleep. So after I've done a page and I go on to the next page, I've got to sleep to wait for the page to generate itself. Now that's good, but you could actually have slow internet, so it slows down. So I ended up using this WebDriverWait with expected conditions. So what this does is from all of my exercises that I've been doing on here, for the very first page, I think I've got it set. I've got a time sleep of 10 seconds, and it seems to work fine. So I don't seem to have any problem with that. So when I've done the query and I do the submit button, the first page comes up within 10 seconds, so that's fine. But for the following pages, what I actually do is that I actually use this presence of an element located. So I actually go and find just an element in the table. So I don't care, I just need one of them just to say, is that present? So has the next page generated enough that it's filled out the table? If it has, then carry on doing the rest of the things. Then go and find out how many rows you've actually got in that thing. So this here, we're actually going through and finding out the length of the table there. And then it goes and prints the number of rows and the number of columns, but we've set the columns as 6 because that's how many we're actually going through. And then we do a little sleep through here. Now this is the thing that was the super thing for me, is that these kept on breaking all the time. So what I ended up doing was, I think in JavaScript it's called a try and catch, and this one here is try this, but if it doesn't work, then break, and then what you do is you just print no results and quit, and then sorry, not quit but continue. So what that does is, because this is an inner loop inside of this, it then goes into the next loop. So if I end up with a short page or something a little bit odd, it carries on going. So it goes through onto the next one. So on this one here, it just jumps out to go through the next lot, which when it jumps out is it goes through into the next name. 4 names in here. So this is what's actually coming through. So it jumps out of that loop, comes back into the upper loop, and it just suddenly says, no, we didn't get any results there, carry on through, but it's written those down. So although it breaks, we're able to continue with the rest of the stuff. So when I did this one here, what was the name through here? So on this one here, if I just run this one will go through and it'll jump through. So I can now do a number of names through there, but what my next problem is, so it's coming through and doing Morgan at this point in time, and it's going to go Blogel, because we got 3 names in here. We got Morgan, then we got Phillips, then we got James. So if we just go through and look back on here again, you see Morgan, and it's only got 2 pages for this. and this one says the maximum numbers have been retrieved, so that's the maximum that you can actually get. But it's only 2 pages, so it's not the 17 pages. So this is the next thing. A lot of the time some of these are failing because I've got something like the name Smith that's got thousands in there, not just 500. So that the next thing that I've actually got to do in here is to come down and do the same thing, but also have an outer loop for the names so that I can work through all of my different names. But I can also walk through and I can actually do time bands. Now I could do that into a loop of the I plus 1 to actually do the dates, but in the end I actually just broke it down to every 10 years. And then I start on the 2nd of the 1st so that I don't have an overlap if somebody's born on the 1st of January, so that it doesn't come all the way through. So this one just does that loop. It goes through the first name. I've highlighted this one would actually tend to have a lot more names. I've actually only just got the one name so that you can iterate through these ones here. So if we just go back through that previous one that we were running through there, you see it's not open anymore because it's actually quit out of the program that we were doing on number 2 requests, and the file for that is table XYZ3. And on that one there, it's gone through Morgan, it's gone through Phillips, and then it's gone through James. So it's done the 3 names and looped through all of the ones that we've got. So that's good. So the next one that we then loop through is that we then have the name, and then we do it in 10-year brackets. And we just run that one there, running through here. Now the thing with this is how do we know that 10 years will always meet the criteria? So for this one here, for that 10-year bracket, there was only 37 matches, so that's fine. But there might be something like Smith of even that 10 years there's not. So while I'm actually also writing this one to one called table ZAB1, I'm also calling it ZAB1 with a log on the end. So if we look at the log one, every time it's going through, now I've got it sort of over iteration, but I'm not that bothered. Again, it's still sort of building the idea of what I want. This is telling me how many pages it's receiving. And as long as it's less than 17, then I know that it's okay. So it's actually looping too many times through here. I should be able to kind of put it further up in the loop so it doesn't count as many. But what it's telling me is that I'm not reaching the maximum number of 2, it may be 3 I suppose. I'm not reaching the maximum number of pages, so I'm comfortable within there. But if I actually find that one name within a 10-year period, like Smith, suddenly from 1985 to 1990 or 1995, there's more than 517 pages, and I'm suddenly saying, well, okay, then I can go back into that one there and run that script in a 5-year period so that we can check to see whether that's going to hit the 17 or not. And if it does, then we can break it down into 2-year ones, and we can break it into a theme up. So that way you know that you're getting the whole history of a particular name for the span of the period that you're looking for. So that's one of the things that we're doing. Now when I actually came through and got this, so this is for birth, I then have to do the same thing on the same names again for deaths. Now because I ended up doing this particular one through here, for these birth requests through here on there, because I broke them down into these 10-year periods from 1875 to 1973, so I suppose that's 10 lots of periods. Then I ended up with about 100 names, of which I think the first one I ended up running was about 50 of them. On that particular one, I actually ran that on my server so that it could just run 24 hours a day. And in fact, it took something like 26 to 28 hours to run the whole thing, and it didn't break. So I was very impressed with the code that it didn't run, and it actually did all of that whole process through there. So the thing that's made me very, very pleased on this is the try wait really was the one that actually solved the issues that I actually had with this particular one through. So the code is here for that, and that's fine. So once I got to that level of things, I suddenly think, well, okay, then I've got the birth side of the thing. I can then use this same script for the death side, so I can scrape all of those, so I can actually do the same bounding for the birth and death and see whatever ones that I can do. Then I can actually take that information So I've got one which is the birth, and I've got one which is the death. And then I can take those and make two data frames. I can make one for the birth and one for the death. And then I can just check and drop any duplicates just to see if there's any that have got the things. Oh, I actually add in the headers at the beginning. And I then, just because I'm looping through so many pages, I don't want to take the header off every single page. So I suddenly say no headers, I'll add the headers on at the end. So that's what I ended up doing through there. So we just drop the duplicates just to make sure that it's as clean as possible. Then if we just look at the data that we're getting in here, we look at one of the earlier ones, you see that what they've got is the ID is made up of two components. It's made up of however many there have been in that year. So this one here is only number 3005 is this particular one here, and this was in 1881, whereas in 1902 this was the 15,807th. So I don't know how those records are done and whether it's a 5, 6 or 7 digit or 4 or 5 or 6 or 7 digit. I sort of have quite tested it out. But I can start targeting those sorts of things to get, so I need to split the year off, the year of the birth, to the actual ID. So that's one of the things I'm doing there. So I'm doing this split and I'm putting them into two separate columns. Then I blow away the original. I'm not too sure whether I blow away the original stuff. Then I just write them out. A lot of times I write stuff out to CV just in case they break at a specific point. Then the next thing which I'm doing is that I'm merging on given name. Now, if you've got a simple name like John, there might be several people who just have only a single name called John. So you might get several matches because I'm only doing this, and this is the first testing that I was doing based on the given name. So it's finding the births and the deaths, and it's just basing on that. Now, to a certain extent, maybe I should actually merge the given name with the mother's name and the father's name and do a concatenation and then compare on those. So that might be a better way of doing it. But anyway, it was the first crack that I was trying with these sorts of things. Now the second one is, once I've actually got all of those, I'm going to sort. Now if you're doing it in Excel, if I'm doing it inside here, and I was actually suddenly saying, well, okay, I'm going to sort on this one here. So if I just get my one through here and just put a filter on there, the first one that I'd sort by was the year of birth. Then I'd sort by the mother's name, then I'd sort by the father's name, and that's when I get it into this structure. So the father's name is the first one that comes up, then the mother's name, then the date of birth, and then you can actually see things are ordered so that you can see which one of the family comes in first, so you can see the ages of the siblings from the eldest to the youngest. So you've got to sort year, then mother's name, then father's name to get it into that order. Now, something that sort of slightly threw me, but it's just a coding method really. Inside of Python, you sort of do it backwards. You do year of birth is third, mother's second, and then father's first through here, but it actually sorts from year through to mother and then to father. And then we can drop duplicates, because we've only matched on given name. So at this point in time, given name is maybe not enough to do, because if there's two Johns, they're going to be, we aren't doing the John by the fact, well, we got the name Drake, but if they could actually have, there could be a John which we've got, well, obviously there will be, we'll have different parents. And so you're going to get a double match, or maybe triple or quadruple or something like that. So we've got to clean out all of the ones which are a duplicate. So that's maybe a bit dangerous. So maybe I've done a poor sort through there. So I've got to think about my sorting on some of these through here. Then I've got to make a subset of this, and the subset is where the mother and the father's name appear more than once. So if there's only one child, then we're not interested in. So we only want to sort on the mother and the father's name so that we can get all of the ones. So if we look at this particular sheet here, we've got the same mothers and fathers' names. On this one, second one here, we've got the same mothers and fathers' names. And again, this one here, we've got the same mothers and fathers' names. Let's just make sure we don't end up moving those over, etc., etc., etc. So that way we can see the ones with the siblings. So any ones that have actually only got one or no children, that we're not interested. We're only interested in the ones with the siblings. Now at this point in time, we've suddenly got ones which you'll find that we've got sisters and brothers all in there as well. Now if you see on here, there's no clarification as to what sex they are. In other words, there isn't a column with F and one for M and F, things like that. So therefore, that was a bit of a challenge, and I haven't really managed that too well at this point in time, but I've explored it. Of when I've gone through, I've started to look at ways of identifying whether a name is male or female. So you've actually got to then look at the given names, and you've got to suddenly say, well, are they male or are they female? Now, another thing, when we're matching the births against the deaths, one of the things that's actually happening is that you might start off with 1,000 births, but you might only end up with 400 deaths. Now, the reason for that is, for when we got to the point of siblings, so we cleaned them out and we got to the point of the siblings. So one of the ones is, if they're daughters, a lot of the daughters would have married. So therefore they've got a different name, and it isn't the same name as the birth and death for a specific name. So you could actually have to track individual females down. So that's a bit awkward. The second thing is New Zealand's quite a small country, and everybody naffs off overseas. So another thing is that there's not a lot of deaths because, well, there's a reasonable amount of death, but a lot of them would have died overseas. So we haven't got any of that information either. So suddenly our information is getting a little bit messy. One, we got females through there, and the other one is we got that. So how do we do it? And then this is where I've sort of got to a point where I've put some stuff into an Excel sheet and had a little bit of a play and looked at female names. Now some of the women stayed spinsters, so they're still there and they die under their own name. Another thing is sometimes the death, I've got somebody who died 16 years before they were born. That was quite impressive. 1906 they were born and they died in 1890. So some of the records are a little bit ambiguous, so you've got to do some cleaning on some of those things as well. So from these massive data sets, suddenly you only get up with a smaller data set. So the next thing that we've got is you're suddenly thinking, well, if I'm just doing siblings, what's fair to do? Because some of the females are going to disappear because they've gone to a different name. So either you spend a lot of energy to go and track to find what those females' married names are, and then see what they died, so you can actually get their death name, their married name, and when they died, to see where they fit in the hierarchy. Or the other thing that you could do is just suddenly saying, well, I'm only going to filter out by people who had males. So the only children they had were males, so there's only brothers into there, because then we can actually be fair. And then all of them die in country, or if they don't die in country, then we acknowledge that there's a gap in there somewhere, and we can acknowledge where they fall into the hierarchy of things, so that we can maybe do some guesstimate. Or maybe we suddenly saying, well, we only actually have brothers who actually all die in the country. So suddenly our data sets start to shrink down a lot. So at this point in time, we've actually got to go through this third step as well. And the step that we've got to go through there is to identify who's a male and who's a female. Now, of the things that I was looking at, as I mentioned before, there was a few APIs that could do this. So you could send a name up to an API and it said, yeah, that's a boy's name. So it come back and say an M. And then if it was a girl, it comes up. One of them I tried, I think it was just a library, and I only got about a 10% hit. So there was so many unknowns, you're suddenly thinking, well, that's not really useful. Another API I tried, the free account would only let you put 10 names up, and then it would tell you what they were and then bring it back again. And other ones were mainly paid ones. But I did come across this one here, this NLTK corpus ones, which actually has two libraries. It has a male library and a female library, and it goes through and actually compares so they can do some identifier. So once we've reduced down to family names with siblings, we can then go through and try and identify what sex they are, so that we can suddenly say, well, if you're a female, show off. If you're a male, okay, then we'll put you into the one. So we've then got another sub thing going through there. So as I'm going through here, I'm suddenly realizing that there's because again, first of all, we've got to do this sort by year of sort by mother, sort by father, and then we've got to find the rows where there's more than one column which actually, oh sorry, there's more than one row that actually has the same mother and father. So that means you've got a sibling. So that's as far as I've got so far. So this was the point where I actually just brought it into the Excel and started playing with it. So at this point in time, I've got to, you suddenly think, well, how realistic is this? Now there's another couple of little twists on here. We're actually looking about who lives the longest natural life of a sibling. So to a certain extent, there's the point of the two world wars, 1915 and the 39-45. So really what you've got to say is, well, we're talking about natural life. Now there will be accidents and things statistically like that, but so hopefully we've got a big enough data set of siblings that we can start comparing these. So we then got to say, well, okay then, if there's that, we've actually got to say anybody who was 15 years old or less in 1945. So therefore you've then got to limit that out of it, because again, you know, the chance of getting a bullet or statistically getting shot or killed over a war is a hell of a lot more likely than in normal life, which is in a sort of a non-war state. So you've got to sort of try and take those. So to a certain extent, you've got to say, okay, then 15 years back, so they weren't old enough to enlist, so they wouldn't have gone overseas because there was no real fighting in New Zealand. You can suddenly say, well, okay, then you can take a range from 1930 through to 1973, which is the data that we can actually do, and then go and scrape on all of those to get all the births and then all the deaths and then what we've got. So suddenly you ended up with quite a small selection because of the fact of people going overseas. So you know, at that point in time, you can suddenly say, well, okay, then who passed away first, who passed away second, and as I said, there's ambiguities with those. So, and then you're suddenly thinking, well, at the end of that, how accurate is that information? So trying to do it in a academic sort of a way, but purely only accessing things from the outside, is being a bit of a challenge. Now, I've hit this point here. I've been able to do some web scraping. I've been able to get quite big data sets. The other thing is also ethnicity as well. With the popular names, there was a few popular names, and one of the biggest popular names in certain areas were things like Singh, because there's a lot of migrations from India or and some of the Pacific places where there was in Asia, and Chinese names as well. But those are actually only one or two generations where they've really come into the country. There were these very early Chinese, but then there's only been a sort of a gentle trickle from somewhere like Hong Kong for Chinese names coming over. So there's these kind of odd names that haven't been able to pick up, and also Maori names and also Pacific names. There was a large group of immigration from the Pacific nations in the 70s because they needed them in the factories to actually start doing production things. So there's this sort of subgroups of which this research doesn't do. So in some ways it's kind of very general, but then it's also very narrow as well. So it brings up all of these questions as I've gone through. So a simple question of which I asked myself has ended up being very, very complicated, and each time I'm actually having to kind of narrow the criteria down such that you then question the validity of the data that you're actually trying to analyse. But so far it's been quite an interesting exercise as far as bringing insights into this. And the other thing that I got really pleased with is that, as I said, I can normally do web scraping at the back end that I find I'm really successful. Well, this one I actually had to come from the front end, and it kept on breaking. But being able to actually add these loops within loops, one for the names, and also then to break down by different date ranges so that I wasn't maxing out on the number of a name within a certain period of time, that it's able to do. And with the logs I can now identify which ones do end up being which groups that I sort of end up not scraping enough from. I can actually see that I've got something to go through there and do it. So as an exercise, it's been I'm quite pleased with this front end scraping going through here, and it's actually it's enthused me enough to actually try it on a few other sites to see if I can do things. Again, I did this when I did the scraping for the birth and death. I actually found that I had to go to another site and do a whole lot of scrapes on names, and that was over several pages as well, and I was quite successful with that. So one that I'm actually thinking of doing now is to actually go onto something like IMDb or whatever it is, or something like that, those sorts of sites with the films, to actually see the ratings that a lot of the films get, so that you can actually just go through and get a whole lot of ratings and suddenly saying, oh well, I'll stream that sort of thing, or I'll stream that sort of thing based on genre or something like that. It's a nice exercise. At this point in time, I paused it because I've got to rethink how I'm filtering, how I'm scraping, how I'm doing things. I found with using the server, where I can actually just do scraping continuously, is great. That pulling in a large data set based on names and things like that. So it's actually a real life question, and only being able to access this information at this point in time is a bit awkward, but that's all I'm actually is available to me that I've thought of so far. So if you've got a suggestion of what other place that I could go to actually get some other information through there. The other thing is getting some names. Now with something like the white pages, it's hard. I think the only way that I can do it is to manually read them, or put them in, or do some scans or something like that to get pages, to get a larger group of names that I'm going through. Because as I said, I've only got 100 that I've actually scraped that I'm actually using at this point in time. So, but I to a certain extent, that's a big enough data set at this point in time to see how much I've got to do to get cleaning out, and also to reprocess this. So I'm not trying to do just a match on given name, but I'm trying to do it on given name, maybe mother's name and father's name, so that I can get a better match on those sorts of things as well. So I'm going to have to concatenate some of those things to speed up the process, or not speed up the process, but to actually know that I'm getting a cleaner data set. I'm not getting duplicates coming, because well, actually duplicates shouldn't be an issue, but to a certain extent I'm not totally comfortable with what I've got so far. So a thinking process at this point in time, getting the data, I'm reasonably comfortable with what data that I'm getting in, that I'm getting the full range of things, and I can just check to make sure that I am, by checking out my logs that I've now got. I can then proceed on to the next one to start trying to, and that's it. I've actually got to put bounds and be very specific about what I'm actually measuring against. Because another thing with that is that how many siblings? If you've got 2 brothers or 1 brother, so if there's just 2 brothers or 3 brothers or 4 brothers or 5 brothers, and the criteria of the order of that, and you're going to get a lot more of the 2 brothers than you are going to get the 5 brothers and things. So there's a whole lot of estimating to do at the other end through there. So the project, please, I'll put these scripts up there because it's sort of like an iteration of the issues that I had. Obviously just grab the last one and just use that to actually work on. This is based on this particular site here, but the logic of the WebDriver waits, the time sleep in here that I've got through there, the targeting of using XPath or things, and also the buy. This was something that I didn't realize. You'd think with Selenium it would kind of be built in, which is the buy, but it's using, I've got to use the buy is by name or by XPath or by CSS selector, and then getting that one through there. And I did find that Bing actually helped me out a bit with that, with actually doing the Selenium scrape through here. Now it might have been easier to maybe do it with something like Beautiful Soup, but I played previously with a Selenium one, and I didn't quite get it right, so I sort of got a little bit stubborn and suddenly thought, no, I want to do the Selenium ones just to see that I can get all of that one right, because it took me a little bit of effort to get that into there, because setting up Selenium with Firefox I had to get a Gecko driver or something like that. Took me a little time to actually work out, so it was worth the extra effort. But I'm very, very pleased with the result. Don't recollect, when I'm doing this one through here, you'll see that all of the it's popping up a browser to actually run that script. And I quite like actually having that visual thing through there. And I'm also going through here, and it counts which page I'm going on. So as I'm looking at the script, I know how many pages it's actually working through. So if I just go through and see where the Selenium browser's been popped up. Now I could do that headless, and I was initially doing it headless, but I actually found it was quite irritating when I was doing it headless, because you didn't actually see what was happening, and you didn't know what page you were on, so you suddenly think, why is it taking so long? Oh, this is really irritating. So I find actually having the visual of the browser showing up each time is a bit more comfortable. But now I'm actually bringing this information through here, and saying which years I'm actually going through and working on. I'm getting that information, so I know how far it's got through the actual iteration of itself. And then another thing through here is I'm doing the iteration, but I don't think I've got each name. So when I'm actually doing a specific name, I should be writing down the name and the year, or that it's going through, to see which part of the loop that it's doing, and then how many pages it's actually got. Or I should do a final count of the page and then say it's 2 of 7 or something like that. So it can be sort of, there's lots of little tweaks that I can actually add to this. But it's coming along, and I'm as I said, because I ran there for something like 28 hours continuously, I'm very impressed with how robust it was. And it just might be because it's set up that the site works very well for it too. So thank you very much for watching. I hope you found it handy. Please give a thumbs up if you found it useful. Thank you.